In this video tutorial, we're going to talk about how to model moving loads and evaluate slabs for moving loads in ADAPTBuilder. We're going to specifically be working in Floor Pro, and we'll work in RC mode. This will basically show us how do we model moving loads. For example, if we have a forklift or a truck and we have multiple contact points, we need to be able to um, position those points in different locations and then be able to envelope results for deflections, stresses, reinforcement, for example. We'll talk about how we can approach that in the program. We'll go ahead and launch ADAPTBuilder. This will be done in Builder 2019. Notice here we've selected Floor Pro. This has PTRC capability, modeling of post-tensioning. We'll go ahead and select OK, and then we're going to open just an existing file here. This file has post-tensioning in it, and there's some ramping at the top. We're going to largely ignore that. We're going to mainly work here in the model space in what we call single level mode. So we've switched to single level. If I go to a 3D view of this particular model, you can see this actually has several different floors, but we're going to just limit it to single level use. So we'll come back and we're going to work on plane 3. Okay, I'm going to go back to my default display. So we'll go over here to default display. That basically turns off the shell elements that we were seeing in the ramps, the tendons, and so on. So in this particular level, we're going to model these moving loads. We're going to save this file. Okay, and I'm going to open up a markup tool. Let's say we have four loads, and these could be represented as small area loads, basically a patch load by some grouping like so. So this grouping I want to be able to place here, maybe move it here, and maybe I have this positioned in 20 different locations on this slab. This grouping could be an axle or an engine, let's say, with an axle in the back, similar to some Ashto HS20 type loading where you have some, distance here and then another distance here. So whatever type of load you're trying to apply, these could be point loads. They don't have to be patch loads. They could also be line loads. We're going to represent these as point loads, and we're really going to just focus on a grouping of 4. And I'm going to have a distance here of 8 feet. And then this distance I'm going to say is 4 feet. And I'm going to say that each of the loads is a 5 kip point load. So the first thing I want to do is establish this set of loads in the model. And I don't really have to place that in the model yet. I can place it outside of the model and then just copy it into the model at different locations. So we'll go ahead and do that. Let's start over in this corner, and I'm going to model a load. We'll go over here to loading, point load. I'll just add one point load at some arbitrary location. If I double click on the point load, in this instance of the program has to be defined as either one of these existing gravity load cases. We're going to ignore the building load cases, EQ and EX, EQX and EQY, or I have to define it as a special load. Okay, and so for each position we're going to create multiple load sets. Okay, so let's go ahead and finish establishing the actual loading itself. I'm going to modify this. Let's go ahead and set that to 5 kips. This is in the Z direction downward, and I'll take that and just modify it by coordinates, and I'll copy that over 5 feet. And then I'll take these, or excuse me, that should have been copied 8 feet. Let me move it an additional 3 feet. And then I'll copy these down 4 feet. So this will be in the negative Y direction, -4, copy. There's my load pattern for this set of point loads and 2 axles, let's say. So if I now go to loading load case, I'm going to assume that I have to have 10 unique positions of these 4 loads in the model. If I actually go ahead and copy this into those 10 positions. Let's assume I have to take this group and move it over 20 feet increments, and then I need to move down in 15-foot increments in terms of my placement. So I'll take this, I'll go to modify, I'm going to copy by coordinates again, and I'm going to say this needs to be copied every 20 feet, and I'm going to copy this 5 times. And we'll go ahead and just dump out these last two. Okay, there's 1, 2, 3, 4, 5 unique positions, and now I'm going to copy down multiple times. So I'll go ahead and select point loads. I'll select by type, point load, and we're going to go back to modify, and this will be in the negative 15. And let's just copy it down. We'll have more than 10 here, but we'll copy this down. Let's say 5 times also. Okay, and I'm going to delete this, and I'm going to move this set inbound slightly. So we'll just select these point loads. I'll move it 3 feet, and then I'll select these ones, move those also in by 3 feet. We just want to make sure they're all on the slab. Otherwise, you wouldn't get that particular load applied to the model. We also have some loads in the opening, so let's move those vertically by 3 feet. There, we'll say this is going to move in the vertical direction. And then this one, I'm going to move up 2 feet. Okay. Now, because all of these are currently represented as dead loads, each one of these has to have its own unique load case. Otherwise, they would be applied at the same time, and we need to be able to envelope the results based on these load sets being positioned individually on the slab. So we have 5 times 5, we have 25 unique sets of loads. And what we're going to do here is go to loading, load cases. I'm going to just add 25 sets here, or 25 new load cases. Okay, 2 more. So there's 25 unique load cases that we can now apply these loads to. And I'll go ahead and do that. I'll start with load case 1 and I'll work down through load case 25. To make this a little easier, I'm going to turn everything off except for my load. So I'll go over to model, I'll turn off slabs, walls, columns, openings, and we can now just easily select these. So to show you an example, I'll take these. Because I'm modifying a group of loads, I'll go to modify selection, and these now become load case 1. Okay, I'll go down to the bottom, and the end one would be load case 25, and I'll go ahead and fill in the rest. Now I'm going to work left to right and just wrap around left to right. Okay, we have one more set here. This will be load case 24, and now they've all been defined. I'll go back and just reset my view using visibility default display. That's also down here on the quick access panel. If I go to loading, show loads, that shows all of my unique load cases for those sets. I also have loading just a regular live load of 75 PSF as well as a dead load of 25 PSF. So within the load combinations, I need to now generate combinations that allow me to uniquely create results for each particular pattern. So I'm going to go ahead and delete out a few of these cases that are not critical for this model. And just as an example, we're going to show how this can be done using strength, dead and live. This is total load, total factored load. And I'm going to repeat this. I'm going to clone this case, 25 times. So you can right click and clone it like so. Okay, so we have 25 new strength cases here, or combinations. You would have to repeat that for any combination you want to obtain results for every unique set of loads. So I'll just add a factor now for each one of these load cases. This is strength 1, and I'll just use a factor of 1 in this example. We're going to go through and just add that factor. Let me go ahead and stretch out this table. Okay, and we can shift that over a bit. We're on 24, and then one more is 25. And now we have our combinations set up here. Again, if we wanted to apply these to different combinations, we would have to recreate this multiple times. So we'll say OK. Now we're going to go ahead and evaluate the slab. So I'll mesh the slab first. Let's use a mesh size of 4 feet. These will be quadrilateral elements for the meshing. And we're now going to execute in single level mode. We're just working in this one level, and we'll look at the results for these combinations. We'll just envelope strength 1 through strength 25, those that we just had created. Okay, that's been done. Coming back to my default display, at this point we can look at unique combination results. The result browser will list all of those strength combos. For example, if I wanted to see the deflection for strength 1, I can review, that this deflected shape. I can go in and check this for different combos. So strength 2, 3, 4. You can see the deflection starting to creep left to right because that's where our load placement is. There is something happening over here that may be just a disconnection between the slab and this column. Let's go ahead and look at that. Yeah, you can see there's something happening there with the ramps, or some disconnectivity. So let's do this. Let's just eliminate those ramps. We don't have to worry about that connection. I'm going to just remesh the structure, and we'll reanalyze this just to eliminate that problem. It's saying there's a tendon outside of the slab when we try to remesh, so that's okay. We can modify the tendon position. We'll go ahead and select this to show tendons, and we'll just make sure that this tendon is in the slab. So it may be out of the slab there. I'll turn the tendons back off, come back and remesh, and let's re-execute. Okay, back to my default display. If I look at the vertical deflection again, there's still some disconnectivity at this location. The issue is actually being caused by the tendons. This is a set of tendons, and because the strength includes the hyperstatic action for the tendons, that's solved uniquely. So we need to eliminate that from the combinations to actually produce a valid deflection result when we have post-tensioning cables considered. So we'll make this easy. For this example, we'll go ahead and just take these tendons, and I'm going to eliminate them from the model. So I'll just use my select by type tendon, And if this was a serviceability case and we had used pre-stressing, which is just the primary plus the secondary effects of the PT, the deflections would be fine. But because this is a specialized case, hyperstatic or secondary only, you get this deflected shape. So it's not unique necessarily to this model. It's unique to the way we solve for hyperstatic actions in the software. So we'll take that, we'll modify, and I'm going to just ignore the tendons for this model. That should help us evaluate these deflections more precisely by using the right set of load cases within the combination. So we'll just execute one more time. And if I go back, let's go back to the strength 1, for example. Okay, so selecting strength 1 yields this deflection diagram now. Let me go back and turn off the shell elements. We have some severe deflection in this panel, so it may be hard to see the change in deflection as we move across the slab with the application of the different moving loads. But we have strength 1, strength 2, strength 3, and you can see this contour starting to shift as we move again left to right. Strength 4, 5, and then if we look at this deflection down here, 1.09, if I go down to strength 25, that will jump a little bit because of the additional point loads in that area. So this is how we can generate results for multiple positions of that moving load. Now for design purposes, we may have to generate design strips. So if we wanted to design the slab and envelope those results, then we get into floor design. We're going to generate strips. I'll use the new dynamic editor found within Builder 2019. I'm just going to create a construction line that kind of goes through these different locations. Okay, we'll do that one more time on this line. Let's resume this. There's the first line. Second line, I'm going to snap near the wall endpoints to pick up that. We'll have to clean that one up a little bit. I'll go ahead and do this line. And then the last line will be something like that. I'll pause this and I'll just move this point back here, and this point I'll move to there. Okay, the same thing here. We'll move this point so it snaps there, and then this point snapping there. These are the strips we'll use in the X direction. Let's go ahead and close that. We would also do the same in the Y direction. I'm going to insert a couple of points here. We'll do point 1 and 2, and just make sure those are located on the wall. For those of you who have used the software in previous versions, there's no need for splitters at this point unless we want to bound off this region. So I'll put a horizontal splitter, let's say here, and another one right there. These are used to just bound the width of the tributary. We don't need them at termination points within the slab region any longer. That's not required in this version. I'll generate the section cuts. Okay, we get our design cuts as shown here. So once I have my design cuts ready to go, now we can design these sections. So we'll use these. There may be some manipulation we have to make. For example, this void area, I may have to stretch the support line over to where that splitter is. But for now, we'll just use these section cuts, just showing how we can envelope the sections for those different load patterns. Once the design is done, now we can select the option for enveloping. We cannot envelope contours, but we can envelope strip results. So I'll envelope, for example, the strength combinations, and if I go now to the design section cuts under actions, bending, these are now my enveloped bending results diagrams for these strips. Now the program has already designed these. If I want to calculate the rebar plan, I could calculate it for the envelope of all combos, or for example the envelope of strength. So if we do envelope of strength, this is the reinforcement required for the enveloping of all of those different unique locations of the moving load. If we wanted to see results only for a particular load combination, for example, strength 1 again, I can always come back to this load selection, select strength 1, and we now get moments for the positioning of those loads over in this location. If I turn those loads back on, for example, I'll turn those on. These are the point loads in question. And I can go back to, for example, strength 2, and we'll see this moment diagram shift again as we move left to right. Strength 3, 4, 5, and so on. Okay, so that's how we would evaluate design strips and reinforcement in the slab for this type of an approach. And lastly, if we run punching shear for a two-way slab, for example, we have the ability to include and capture the different strength combinations that were generated directly in the run of punching shear. So I would set up my punching shear options, and then I could go ahead and I'm going to turn off this option for minimum punching shear rails or studs for drift. I'll execute the shear. The program will calculate that for all combinations, and ultimately the result that you get either graphically or in tabular format would include the effects of all strength combinations. So looking at punching shear, this is for strength 5, whatever is selected in the load combos under strength. Here we have strength 5. If I look at the reinforcements for strength 5, that gives me one particular solution. If I look at the reinforcement for strength 23, that might give me a different solution, especially where you have those point loads that might locally affect the design of a column. Or I could also just do the envelope of strength again, and you saw there was a small update there. This can be produced in a report format under punching shear report. This is an Excel report that provides output for all strength combinations, and you can ultimately get the punching shear reinforcement report, which is shown here. This is an envelope of strength. If you want to see individual combination results, then you have to go back and use the option for turn off provide uniform spacing of studs. So once I do this and I regenerate the solution, the punching shear report will be shown for the envelope and all different strength combinations. So back under report, this will be a longer report because of that, but it will produce that set of data for you. This is strength dead and live, strength 1, strength 2, and so on. So this shows me the results for everything, including the envelope at the end. If you have any questions about this process, please feel free to contact us at support@adaptsoft.com. Thank you.